My dear friends, welcome to Rajshekhar classes on Applied Data Science with Python. This is lecture number 588. In this lecture, we will try to understand architecture of the SKIPGRAM. In CBOW, which we have seen in the previous lecture, we are trying to predict the focus word given context words. That's what we are trying to do. In SKIPGRAM, we will just do the opposite. We will try to predict context words given focus word. This is exactly the opposite task. Just try to recall CBOW. This CBOW, how many weights we have here? We have lots of weights here. We have softbacks with n units. This is your CBOW, isn't it? Just try to recall this one. In CBOW, just if you observe here, let me show the weights here once. This is this one. I have V cross n, here n cross V. Of course, here also I will have V cross n weights. Here also I can V cross n weights. Here n cross V weights. This is your CBOW, isn't it? Just if you go to your SKIPGRAM look like exactly opposite. This is my input. Input is my focus word. I have my input here. I have only one input. That is my input is focus word. Let me say it is focus word is represented as a V-dimensional vector, isn't it? V-dimensional one-hot encoded word, isn't it? What I have here, my focus word is F. After this is my input. Now what I have to do? Once if I take focus word as an input, I will connect this to my hidden layer. Let me say my L1. L1 is hidden layer. This is my hidden layer. My hidden layer again has linear activation units. My hidden layer is of size, let me say its size is n dimensional. It has got n dimensions. It's an n dimensional hidden layer, which means n neurons here. How many neurons we have in this particular hidden layer? I have n neurons. N neurons here. This is fully connected one. So the number of weights that I have here, this is, what is this? W of, this is my input. This is my hidden layer. Just I have input layer and hidden layer. My next layer is hidden layer. What do I want to predict given a focus? Anyway, how many weights I have here? W of V cross N. Why? Because it has got V inputs. If you observe this one, what are the inputs here? This is V is input, therefore I am writing V. And what is dimension of this one? N. Therefore, this is V cross N. That's why I am writing W of V cross N. What do I want to predict given a focus word? What is my task? What do I want to predict given a focus word? I want to predict context word 1, that is C1, context word 2, that is C2, so on. Context word K means from F. What I have to do? If I have F is my input like this is F is input. What is my output? My output is C1, C2, so on, Ck. Context word 1, context word 2, so on, context word K. From this input, from this input, I will connect to softmax here. Let me connect to softmax. Yes, just see. This is softmax. This is after I want to, I wanted to output, softmax has to output C1, isn't it? Let me say output of softmax is C1. In similar manner, I will create one more softmax here, which will output C2 again. These are fully connected. Softmax output is C2, and all these are fully connected in similar manner. I have softmax. I will connect. I have one more softmax trying to predict C3, so on and so forth. I have K softmaxes which predicts CK. This is my output layer. What is my output layer? In output layer, I have different softmax, isn't it? So in output layer, I have K softmaxes. That's important. In output layer, I have K softmaxes because I want to predict K context words. That's important. I have K softmaxes. With that particular K softmaxes, I will predict K context words. Each of my softmax has V units. That's important. Each softmax has V units. So this is what is my this is n cross V. If you observe carefully, why it is n cross V vector? What is the input size here? This is n dimensional, therefore n. What is the size of the softmax? Size of softmax is V. Therefore, this is n cross V, this is n cross V, this is n cross V. How many such n cross V's are there? There are K outputs, K softmaxes are there. How many softmaxes? There are K softmaxes. Therefore, I can say I have it is exactly if you think about this, it is exactly a sort of inversion to CBOW. Remember, linear activation units are very cheap. That's you must understand. Your linear activation units are very cheap to compute. We have only one softmax here in CBOW. Just try to recall. This is our CBOW. In CBOW, in the case of CBOW, in n-dimensional hidden layers, you have linear activation units. In the case of SKIPGRAM, just see, this is case of SKIPGRAM. This is connection. These connections are just if you observe carefully, these connections are small compared to this one. Just see, this is about CBOW. This is CBOW architecture. This entire diagram is CBOW. Here you have many connections, V cross N. Here you have V cross N. Here also you have V cross N. How many V cross N's here? You have K V cross N's here. That's important. This is about CBOW. This particular diagram is related to CBOW. Now what about my this SKIPGRAM? Just if you see here I have only one WV cross N. In the case of SKIPGRAM, these connections are small. That's what I'm saying here. Just see here, these connections are small. Just it's an inversion. Just see here, these connections are small. Just compare compare with CBOW, isn't it? In the case of SKIPGRAM, these connections are small, WV cross N, but you have K softmaxes. That's important. In the case of SKIPGRAM, I have K softmaxes. Just compare this diagram with the CBOW, isn't it? I have K softmaxes. Think of trying to create K multi-class classifiers. Just we are trying to create K multi-class. What it says, just see, K multi-class. We are trying to create K multi-class classifier. This is one K multi-class classifier, multi-class classifier, multi-class classifier. Totally, how many multi-class classifiers? We are trying to create K multi-class classifiers. You are trying to create K multi-class classifiers. If you think about computationally the number of weights in SKIPGRAM, how many n cross V weights do you have? You have K n cross V weights. Just observe this carefully. Just let me take how many n cross V weights. This is first n cross V weight, second n cross V, third. How many such n cross V weights are there? You have K n cross V weights, isn't it? As you have to predict K context words. And n cross V is the number of weights you have here. Just see here you have V cross N or n cross V. This entire thing is contributing to this particular time. N cross V plus N cross V plus N cross V. How many times? K times. Therefore, it is K n cross V. Here I have V cross N. Just I am writing V cross N, isn't it? How many weights you have? Total number of weights. If you add this one, what is this total number of weights? K plus 1 into, what is this? This is K plus 1 into N cross V weights. Even in CBOW, just try to recall in CBOW, you have this, see, in CBOW also, you have total number of weights, K plus 1 into N cross V. What is the reason? Just see here, you have V cross N, V cross N, V cross N. How many are there? As you are taking input in CBOW, K context words as input, K into V cross N. That's what it says, K into V cross N. Another weight is here, N cross V. If you add all of them, Even in CBOW, you have V cross n k times. So the total number of weights that you have here is k into V cross n. How many weights do you have? So the total number of weights that you have in CBOW is k plus 1 into V cross n. So the number of weights in CBOW. So the number of weights. So the number of weights in CBOW and SKIPGRAM, both of them, you have k plus 1 into n cross v weights. But in CBOW, you have only, just if you observe, in CBOW, this is CBOW. In CBOW, you have only one softmax. Just understand, you have only one softmax in the case of CBOW. Just see, this is only one softmax in the case of CBOW. This is CBOW architecture. You have only one softmax to train because you are trying to predict the focus word only. You are trying to predict only one target word. In the case of SKIPGRAM, you are trying to predict, you have k softmaxes. Why? Because here this is architecture of SKIPGRAM. You have to predict k context words. Therefore, you have k softmaxes. You are trying to predict all the k context words. In SKIPGRAM, I have more softmax functions than in CBOW, isn't it? In SKIPGRAM I have more softmaxes. In the case of SKIPGRAM, I have more softmax functions than CBOW, isn't it? Hence, SKIPGRAMs takes more time. SKIPGRAMs is computationally more expensive. So if you want to compare CBOW and SKIPGRAMs, the CBOW has major advantage. What is the major advantages of CBOW? CBOW is typically faster to train than SKIPGRAM, isn't it? Because SKIPGRAM has k softmaxes and CBOW has one softmax. This is one of the reason. The second thing is CBOW works very well. It works better for frequently occurring words because the word that occurs frequently, look, CBOW structure, this is in CBOW structure. In CBOW structure, if a word occur more often, it will have more training points to correspond, more training points to that corresponding points. Let me say, let's assume there is a word which occur lot of times, W1. Let me say W1 occurred more frequently. You have more context words corresponding to it. So CBOW tends to work well. There are many other reasons. So CBOW tends to work well for frequently occurring words, while on the other hand, SKIPGRAMs are slower, but they can work with smaller amount of data, isn't it? They can work with, advantage of SKIPGRAM is they can work with smaller amount of data, isn't it? That's important point. This is about SKIPGRAM. They can work fairly well. They can work fairly well with smaller amount of data than CBOW, isn't it? SKIPGRAM can work with smaller amount of data. It also works fairly well for infrequently occurring words. That's important. It's opposite to CBOW. If you think about it, SKIPGRAMs are much harder problems. SKIPGRAMs are much harder problems. SKIPGRAMs are much harder problem than CBOW. That is important. Just see, your SKIPGRAMs are much harder problems than CBOW because we are just giving one context word, isn't it? Just we are giving one context word and we are trying to, we are just giving one context word, or we are just, in the case of SKIPGRAM, what happens? We are just giving one focus word, isn't it? One focus word and trying to predict k context words. I will repeat. In the case of SKIPGRAM, we are just giving one focus word and trying to predict k context words. So SKIPGRAM problem is much harder. If somebody gives you a word, let me say, if somebody gives you a word sat, let me say, give me sat. Imagine how hard it is to predict, the cat on the wall. Isn't it? Even for humans, it is harder problem. Why? Because somebody gives me sat and asks me to guess the other words. It is difficult for humans also. That is the case with SKIPGRAM. In CBOW, what do you get? In the case of CBOW, just check. In the case of CBOW, what happens? This is reverse. These words will be given. Which words will be given? This opposite. This one will be given, isn't it? This this one reverse means what? Actually, here sat is given. You have to predict all the words, isn't it? Now these will be given. These will be given. This. Now which one you have to predict? Which one you have to predict? You have to predict this one. It is harder problem in the case of SKIPGRAM, isn't it? In the case of SKIPGRAM, for given sat, in the case of SKIPGRAM, they will give this sat. You have to predict all these words. It's difficult. But whereas in the case of CBOW, they will give these many context words. Let me say C1, C2, C3, C4, C5. This is my focus word or target word. By using this much of information, predicting this is easy. But whereas in this particular case, they will give this one. This is input. This is input. Which one is input? This is input. This means this is output. This and this is output. It's difficult. In the case of SKIPGRAM, just seeing one focus word, predicting these many context words is difficult, isn't it? For example, if someone give the cat on the wall, this is something like fill in the blank. This I can fill it little bit easy. Why? Because I know all this information. I can say like this. It is something like fill in the blanks. This is blank. This is given. This is given. This is given. This is given. Now I have to fill the blank. It is easy. It is no. Actually, just let me explain. Maybe in the case of SKIPGRAM, what happens? What is your input? This is my input. This is my input. What is the output? This is output. I will repeat. This is my output. This is about SKIPGRAM. It is something like you will give input sat. Now you have to predict these many words. You have to predict the. You have to predict cat. You have to predict on. You have to predict the. This is difficult task. By just giving this input, predicting these many context word, by giving just one focus word, predicting these many context words is difficult even for humans. It's same case with same case with SKIPGRAM. But whereas in CBOW, what happens? Just see. In the case of CBOW, it is completely reverse. What will they give? This is context word 1, context word 2, context word 3, context word 4, context word 5. This is my input. What is my output? This is output. This is also input. Means, what does it mean? This is given, this is given, this is given, these many context words is given. I have to fill this blank. Filling this blank is easy, isn't it? Compared to this one, here what's happening? This is input, this is input, these many blanks you have to fill. You have to fill these many blanks. 1, 2, 3, 4, 5 blanks have to fill for given one single input. Here, 5 words is given. I have to fill only one blank. It is just like fill in the blanks. Just try to relate this concept. Think of like fill in the blanks, isn't it? It's like filling the blanks. You are given all surrounding words. Here in the case of CBOW, you are given all surrounding words, and you are given the blanks. These are surrounding words. In the case of CBOW, all surrounding words are given. These are surrounding words, isn't it? Now you have to fill this blank. It is much easier task than SKIPGRAM. But in the case of SKIPGRAM, by using single focus word, single target word, you have to fill these many blanks. That is difficult task. I think I am repeating many times as it is important. I will give you the word that is there in the blank, and I will give you in the case of SKIPGRAM, I will give you the word here, and you have to predict these many context words, and you have to. SKIPGRAM is much harder problem. SKIPGRAM SKIPGRAM is much harder problem to solve, because it is harder because you are solving the harder problem. It is also much more powerful when you solve it by just giving one word. In the case of SKIPGRAM, just you are giving just one word. Just observe, just giving this one word, and you are predicting K words, you are predicting K context words, therefore it's difficult. You have to predict all the surrounding words. Just by using this single focus word, you have to predict all the surrounding words. Whereas in the other case in CBOW, given all the surrounding words, this will be input. Given all the surrounding words, are context word, you have to predict this one. This is output. Yes, you have so many context words. Predicting one target word is easy. That is the CBOW. Given all the surrounding words, predicting it like filling the blank. It's easy compared to the CBOW is easy compared to SKIPGRAM, isn't it? How do I get the weights in both the cases? In both the cases, just see here. In the case of what's happening? What is this? One target word. Here, this is SKIPGRAM. This is SKIPGRAM. How many focus words? One focus word. You have to predict so many context words. It's difficult. Whereas in the case of CBOW, just see. In the case of CBOW, what is my input? The cat on the wall. Output is sat. It's easy, isn't it? Just say the cat on the. What is this? This is CBOW. You have so many context words. You have to predict sat. It is easy to predicting sat, isn't it? If you compare number of weights, just compare all these things. Again, I am repeating. In the case of SKIPGRAM, this is input sat. These are the outputs. By using single target word, you have to predict these many context words. It's a difficult task. That is about CBOW architecture. What about my CBOW? In the case of CBOW, just see how many inputs you have. You have so many inputs. You have to predict only one output. This is easy. It's easy. Why? Because you have given many surrounding words and you are predicting one target word. Therefore, CBOW is easy. If you compare number of weights in CBOW and number of weights in SKIPGRAM, that is K plus 1 into N cross V. Just try to recall. In both cases, you have same number of weights, isn't it? Now, what is this? Let me assume my capital N equal to 200 and K equal to 5. Let me say V equal to 10,000, isn't it? If you substitute all these values in K plus 1 into N cross V, almost I may get 1.2 crore weights to challenge. Training these many weights is a challenging task. Even though I have 10,000 size of vocabulary, and the context size and the context word size is 5, only 200 dimensional vector, I still have 1.2 crore weights to train. This can take forever to do it. So we need to optimize training somehow. That's important. As it has so many weights, we need to optimize the training somehow. You need to somehow find some algorithmic optimization to achieve this. There are a couple of algorithmic optimizations that we will see in my next lecture. I request all of you to go through this lecture. If you have any difficulty, please keep a comment. Just compare this architecture. That is important. Just see, in the case of this is SKIPGRAM architecture, where we are giving SAT, one focus word, and you are trying to predict many context words, cat, on, the, wall. It is always difficult. By single focus word, you have to predict so many surrounding words is difficult. But in the case of CBOW, you have so many surrounding words, that is context words given, and you have to predict one focus word or target words. This is easier. The CBOW architecture is easier compared to SKIPGRAM. Just try to understand the basic differences between these two architectures. If you have any difficulty, please keep a comment. Thank you very much.